Hello everyone. Today we are going to see some analysis part on static force system, static force analysis required in particular mechanical system. Let us take an example how to analyze if we consider static force analysis only on the given system or mechanism. Let us take this example problem. It is determine the required input torque on the crank of a slider crank mechanism for the static equilibrium. So, in this case, the slider crank mechanism, we need to draw the configuration diagram based on the given statement of the problem. This we can simply slider crank mechanism we can draw. This is the crank and connecting rod, and connecting rod is connected with the piston. Piston is guided in the guides, and crank is going to rotate. In this problem, it is mentioned that the load acting on the applied load acting on the piston is 1500 newtons. 1500 newtons. The lengths of the crank and connecting rod are 40 mm. Crank length is 40 mm. Connecting rod length is 100 mm. And the crank has turned through 45 degrees from the inner dead center. At this position, we need to analyze this mechanism. So, in this mechanism, in this problem, we need to find the torque, input torque required to rotate the connecting rod so that the system is maintaining static equilibrium. Now, coming to the problem, solution of the problem, we can use either way. By directly identical relations we can apply, or by drawing configuration diagram we can find, because let us say the angle made by crank with the central line theta is given 45, then the angle made by connecting rod with the line of stroke or center line we can say this is, let us say, pi. Then once you draw configuration diagram based on the given input specifications, then you can directly measure this angle pi. Otherwise, you can use the relation sin pi equal to r by L sin theta. You know that this is, okay, this vertical height we can write, this is crank is r, let us say connecting rod is L length, L is 100 given, r is 40. So, r sin 45 must be equal to L sin pi. So, that is the relation used. That's why it is written sin pi equal to r by L sin theta. From the diagram also you can understand this. So, we can find pi angle that we are going to get 16.44 degrees. Now, coming to the graphical analysis, you can isolate each part and draw free body diagram and find unknown quantities, or else if you really know or remember the required relation, you can apply that. Suppose graphical solution, I am going to take here the free body diagram of piston, which is called slider. Then piston is under the action of 1500 newtons force on the external force or applied force. Then it is connected with the connecting rod. Then as we know that constrained force, we are isolating one body from the other. So, we need to show that the reaction of the connecting rod on the piston. Reaction of the connecting rod on the piston. So, we can apply equilibrium equation. This angle we know that this angle is the pi. Okay. Then if we apply equilibrium equation, we will get, this is Fc I will mention. Here it is given F rod in the equation. So, Fc cos pi equal to 1500 as you know, which is we are applying equilibrium equation, all the algebraic sum of forces in all in horizontal axis, x-axis direction is 0. That is the equation we are applying equilibrium equation. From this we can get FC is 1500 by cos pi. So pi is 16.44 degrees. So we will get FC is 1566 newtons. Okay. Then now we need to calculate, because the required quantity is the torque on the crankshaft. The crank effect, that is Ft is the crank effect. Diagrammatically we can see crank effect. Diagrammatically we can see that this is the connecting rod, and this is the crank, this is the connecting rod and piston. So crankshaft, it is connected with the crankshaft. Then the crank effect means the force which is acting in this position. Okay, this is the configuration given. The force which is acting on the connecting rod in the direction perpendicular to the connecting rod position. Perpendicular. This is the crank effect. This is Ft we have said. But the connecting rod, force in the connecting rod, we have seen F rod or Fc. As in the relations mentioned F rod, I am writing Fc or F rod we can say. Okay, this we have estimated already. So how do we get that the force on the Ft, crank effect? So if we see, we can do it in either way. By suppose the Fc is, if we extend Fc, this will go like this, Fc. Okay, so ultimately our object is to find the torque on the crankshaft. The force on the connecting rod in the direction of the force on the crank in the direction of connecting rod is Fc. Because if you draw free body diagram of this crank, then the reaction of connecting rod on the crank is this one. Okay, so the crank free body diagram if you draw, then there is a reaction from the connecting rod on the crank. This is Fc, as we found already this value. Now what is the movement of this Fc about this, let us say A, crankshaft? Then we should write, if we want to directly take Fc terms, then draw the line of action of Fc at A, then perpendicular distance. This perpendicular distance I want. Is it this perpendicular distance? What is this value? Then we know that this angle. What is this angle? This angle is, because this is, we know that this is theta, and this connecting rod, it goes like this, then this angle is pi. Then this angle comes theta plus pi. So now perpendicular distance I want. Then this length, we are using crank length is r. So r sin theta plus pi, is perpendicular distance between the load Fc and the line of action drawn at A, same, the perpendicular distance between these two parallel lines. So obviously we want to get the torque on the connecting crankshaft at A, then this Fc into r sin theta plus pi, means perpendicular distance. As you know that how to take moments about A, then Fc into perpendicular distance. So we know Fc, we know r, we know theta plus pi. Directly we can write the calculate the torque. Okay, or if you want Ft, okay, then you can see Ft is Fc sin theta plus pi. Okay, Fc is Ft sin theta plus pi, because this is theta plus pi, this is perpendicular I want, perpendicular. This is perpendicular line. Okay, this is perpendicular. So then perpendicular. So you know that this angle is theta plus pi. So you can calculate Ft equal to F rod sin Fc sin theta plus pi, and torque equal to Fc r sine theta plus pi, or you can use these relations. If you know Ft exactly perpendicular, then Ft into r will give torque, or else if you take only Fc, then Fc is the distance, perpendicular distance is r sine theta plus pi. So Fc into r sine theta plus pi you can write and calculate the torque. Either way, this torque is, you are going to get this torque value, okay, from this relation. So this is 54.9 newtons. Newton meter actually. Okay, Newton meter. So this is the torque. Okay, if you use R in mm, you can write mm. Okay, then same problem we want to do in dynamic analysis. As you know that in dynamic analysis we need to consider inertia forces and inertia couples. So how do we do that? In the problem statement itself, we should know the specification point. The mass of the links must be given, all the links mass. Then you have to find acceleration forces and acceleration couples, that is inertia forces and inertia couples. You need to have, because the relation for inertia forces is mass into acceleration of that particular point, that mass center. Okay, then G I will write mass center. Then the inertia couples also you can find mass moment of inertia of that particular link into angular acceleration of that link. These two will get minus sign, because acceleration, inertia force is opposite the acceleration of the link or part or system element of the body, and similarly inertia couples are opposite direction to the accelerating couples. So we can find this acceleration of particular mass center of these links, each link. Similarly, acceleration, inertia forces as well as inertia couples of these links you need to find. Then how do you find inertia couples and inertia forces and inertia couples? First you need to know mass of this link. Let us say this is fixed link 1, fixed link, so let us say A, B, C is the point connected at the link D, slider D and C. Then A, okay, then AB is the crank. Then what is the inertia force on the crank? For that you need to draw velocity diagram of this given configuration diagram. From velocity diagram we are going to know acceleration of mass center of crank AB, mass center, let us say GC mass center. Similarly here connecting rod GCR, connecting rod mass center. Generally how do we identify mass center? Generally if link is made with uniform cross section and length, then we can consider midpoint of the link is the mass center. Similarly connecting rod. So from the velocity diagram you are going to know mass acceleration of the center of the crank. Then mass is given in the problem statement itself. Then this is the inertia forces in the crank. Okay, minus sign. So substitute these values and find. Similarly inertia couples, mass moment of inertia of crank. So this is, you know that I can be calculated using mk square, radius of rotation into mass, radius of rotation of this mass center. Okay, so this is half of the length and mass of the crank. So you can have angular acceleration of crank of mass center from velocity acceleration diagram. You need to draw, it does mean you need to draw velocity diagram of for this configuration as well as acceleration diagram. From the velocity diagram you are going to find angular velocities. Using those angular velocities, you can construct acceleration diagram. From the acceleration diagram, you can find acceleration of various mass centers of the links. Then use that value and find inertia forces of a particular link. Similarly, connecting rod also, you can take angular velocity of connecting rod from velocity diagram and angular acceleration of connecting rod mass center from the acceleration diagram. You can calculate easily. Okay, you have studied already thoroughly these concepts in kinematics of machinery first part. So you can do that and estimate similarly inertia forces in the connecting rod and inertia couples in the connecting rod. So once you have these quantities, then show these in the diagram. Because what is the external force in this configuration diagram? Only on the piston 1500 newtons applied force on the piston. Then from the velocity and acceleration diagram, you will accelerate, especially from the acceleration diagram, you can know that direction of these acceleration inertia forces direction. For example, it is directed this much inclination. From the acceleration diagram, you can understand the directions. So similarly here, let us say this is the inertia force, which is opposite to the accelerating force. Then this is the inclination of inertia force. Similarly, inertia couples directions also we can understand from acceleration diagram. Okay, let me say inertia couple is this one. So now you consider this entire system as static problem and apply moments or whatever required moments or force equilibrium equations. Then find the input torque required to maintain equilibrium of the system. Input torque, this is inertia torque, the inertia force on connecting rod, inertia torque. Input torque, how much input torque here you have to apply such that the system is going to maintain static equilibrium. That you need to find from this problem, which is considered, this analysis is, when you consider this analysis, dynamic force analysis. I think you are able to understand that static force analysis, you need not get any inertia forces, inertia couples of any link in the mechanism. Simply from the given force, you can find the required quantity. But in case of dynamic force analysis, apart from applied forces, you need to estimate inertia forces and inertia couples of each link by identifying, locating mass centers of the link as midpoints we will take as we just discussed. Then you can find what is the torque required, input torque required on the crank, so that the system is going to maintain equilibrium. This is about dynamic force analysis problem and the difference between these two. Static force analysis, we consider only applied forces. Dynamic force analysis, we need to estimate inertia forces and inertia torques of each link at the mass center of that link. Of course, masses of each link will be specified in the problem statement. This is about static and dynamic force analysis. Okay, let me stop here. Thank you. Thank you one and all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.